Aromatics. So let's take a look here at this next section called aromatics. Now you might remember me mentioning that in our last lesson we talked about aliphatic compounds. Now aliphatic hydrocarbons are those carbon compounds that basically before this point, we've taken a look at only aliphatic hydrocarbons, meaning anything that's an alkane, an alkene, an alkyne, any branched isomer of any three of those, or a cyclic molecule, anything that we've talked about so far is aliphatic. And I said that we're going to compare those to aromatic molecules. Now, aromatic molecules are a component of some of our natural gas refining that we have in Alberta. And aromatic compounds are anything that have generally an aroma. So we call them aromatic because they do have generally a scent to them. Now, often we have aromatic compounds that are also in things like flavorings and anything that has a great deal of scent to it that is also used in industry. So what we have found through some studies, though, is that aromatic compounds are often carcinogenic or they're cancer-causing. So we have to now be very careful with what we use aromatic compounds for, and we see that definitely we can revise aromatic compounds in a way to be a little bit more safe in terms of uses where we are exposed to them as humans very frequently. So let's take a look at what an aromatic compound is. So an aromatic hydrocarbon are compounds that contain benzene. Now, benzene is this 6-carbon cyclic molecule with alternating double bonds. So what you'll see is this sort of our line diagram on the left here. And if we look at our structural formula, we have 1, 2, 3, 4, 5, 6 carbons, each with a double bond between each other carbon. Okay, so alternating double bonds in that ring, and each has a hydrogen coming off of each carbon. Now, one thing to keep note is that because of the nature of this molecule, and because of the nature of the sharing of these electrons in this compound, what we see is that each bond that's in this molecule, so if we zoom in here, each bond, it's a bit blurry, will alternate between this location and this location. Okay, this bond here will rotate between its original location and this location. And this guy here on the left will alternate between where it's at and this location. And this is what we call oscillating bonds. So essentially, because of the electron sharing, because of the nature of this molecule, again, these can switch locations of the bonds. Okay, so generally when we look at a benzene ring, okay, we like to draw it as a 6-sided shape with a circle in the middle. Now the circle in the middle essentially just represents the fact that they are oscillating bonds, or that these bonds can be mobile in a sense. So we just draw it with a circle in between, and that just means that there is in fact alternating carbon double bonds in the center of that molecule. Okay, so we have benzene, and these things are all, each one of these diagrams represents the exact same thing, and they're all called benzene. So we have, again, a new way to name these things when we're naming these aromatics. Okay, if we have benzene as a functional group, which means that benzene is as a branch, okay, it's a branch off of our parent chain. Okay, that's sort of another way to think of a functional group. We would call that branch a phenyl group, okay? Phenyl, and be careful that you do have a YL. Again, remember that YL represents a branch, okay? So that is consistent with what we've seen so far. Where they got the name phenyl, I'm not sure. It's not from our benzene name, but it is representing the exact same thing. So we have a phenyl. Okay, if it is a ring as its parent chain, the parent chain is the benzene ring, okay, we call that a benzene. So if we have the ring with other things coming off of that ring, okay, we start with it being benzene as the parent chain. So let's take a look at some examples here to compare these things. And again, anything that you see this compound in it, okay, this is equal to aromatic. Now, the one thing that I've noticed students can sometimes get mixed up in our examples is they will see something that looks maybe like this. Okay, and they see double bonds, they see a five-sided shape, but this is not an aromatic. Okay, this is not a good drawing of an aromatic compound. It is not any compound that has alternating bonds. It has to be this six-sided shape with our alternating bonds in the middle, and again, each of these points has a carbon, or a hydrogen, pardon me, coming off of it. Again, it can't be anything, it can't be an eight-sided shape where we think, okay, well, if there's alternating bonds in our eight-sided shape, then that's an aromatic. No, can do, that's not aromatic. The only thing that is aromatic is something with a benzene ring in it. Okay, so let's look at these two examples here where we have a branch as a phenyl group and a main parent chain as a benzene ring. So our first example here, this is what I would represent as a benzene. Our parent chain is our benzene. And a general rule of thumb is if you have branches coming off the benzene that are separate branches, they're not all one long chain, then that is going to be benzene as your parent chain. Another thing to consider is if there is a chain coming off of your benzene ring that is 6 carbons or less, it's probably going to be a benzene as your parent ring, and then that 6 carbon or less chain coming off of it as the branch of that benzene ring. Okay, again, if you have a branched chain that's coming off of, like if you have a branched branch, in other words, coming off of your benzene ring, it is not going to be benzene as your main parent chain. It is going to be a group. So this guy here, A, is a benzene, where this guy here, okay, is going to be one of those phenyl groups. And we're going to look at how to name this. In our first example, in example letter A, we see that benzene is our parent chain. As always, I'm going to write down benzene, okay, and the E and E represents our double bonds that are in this molecule. Okay, and I'm going to write that down first. Now, what I see here is that I have 3 branches. I have 2 methyl branches, and I have 1 ethyl. Okay, so when I go to name this, I'm going to give priority to my ethyl group, partly because it's better to have my ethyl first because it's alphabetical. So if I have the smaller number with my lowest alphabetical letter, then that's probably going to be the best way to do this. So I have 1, 2, 3, 4, 5, and 6. So when I go to name this, I have 1 ethyl, 1 ethyl, okay, and then I have 2, 4 dimethyl, if this will squish in, benzene. So I have 1 ethyl, 2, 4 dimethyl benzene, and that is how I would name that. Okay, so our naming system for these aromatic compounds isn't too crazy or complex. Again, if our longest parent chain or our main component is the benzene ring with branches coming off of that, it is listed as a benzene, whereas in our example B, we have a phenyl. So how do we name this? Now, in this case, we have 1, 2, 3, 4, because we have 3 carbon groups here. So I have 1, 2, 3, 4, 5, 6, 7, 8 as our chain coming off of it. Now, notice that this has to be our parent chain because this parent chain itself has a branch off of it. So this parent chain has this branch here as well as this phenyl branch below. Okay, so the way that we go about naming this is the same as per usual. We name our longest parent chain, which we said was 3, 4, 5, 6, 7, 8, I believe, carbons. So it's octane. And again, we always give priority to the lowest alphabetical or our alphabetical order. So this group here is C3H7, which is a propyl group. Okay, so we have a phenyl and a propyl, meaning that we put our phenyl group first. Again, because there's no double or triple bonds in this chain, we're going to number this, and I would say that if we number it from right to left this time, we're going to get our lowest numbers. So we have 1, 2, 3, and 4, whereas if I number it from the other way, I have 1, 2, 3, 4, and then 5. So because of that, I'm going to just erase these numbers because they don't matter. Okay, and so I have my groups to be, I'll do my phenyl first because pH comes before PR. So I have 3 phenyl, or phenyl, however you like to pronounce that. Okay, 3 phenyl, 4 propyl, octane. Okay, so again, please notice the difference between naming this as a benzene versus a phenyl group. Notice the benzene itself is branched, where this is a branch off of a main chain. So those are the 2 ways that we name these aromatic hydrocarbons, and you will see them as we continue through our organic chemistry unit, and you do definitely have to be able to recognize them and tell the difference between an aromatic hydrocarbon and an aliphatic hydrocarbon. Again, the difference is this benzene ring that's present. So please do not get confused based on a cyclic alkane or a cyclic alkene. It is not the same thing as this benzene ring. All right, that's it for aromatic hydrocarbons. Like always, good luck.